So where it's used, sorry for the discoloration of the slides, but the text is here. So so we have a list of some of the Gurobi's customers. I mean, there's no industry, there's no major organization of a significant size that's not using Gurobi or considering using Gurobi. These companies are here, mainly I wanted to make the point that we cross all industries and in all organizations. A lot of charity organizations use this to optimize their operations. And so here are three in particular. The NFL, they do a scheduling application that's really hard to solve. It takes, last I heard, their model took 58 hours to solve. And as you can imagine, there are lots of things they're trying to do. They want to make the fans happy, the owners happy, the advertisers happy, the players happy. They want to make everyone happy with these models. And so there are a lot of conflicting interests involved in this really difficult one to do. And so it's a great example of where optimization can find the best answer to a complex set of choices. SAP uses this in their supply chain applications, all of them. So they embed Gurobi because they want to have the best performance they can get on these models that they're running for supply chain problems all over the world. And utilities is a very popular category. Popular, I mean, where optimization is used a lot. And NY-ISO is one example where they're deciding when and how to turn on and off their power generation units in, I believe it's in real time. Actually, I'm not sure of that. Oh yeah, here it is, it says real time. So that's another common application. The utilities doing what they call unit commitment problems for turning on and off different facilities of generating power. Sorry again for the discoloration of the slide, but the message here is that the list is long. The number of applications for integer programming in particular, that's just one of the algorithms that Gurobi has inside of it. For integer problems, the list is very, very long. And really, we'll find new ones probably every month is a bit overstating it, but certainly we find new applications for optimization every year. We see them new to us at least. Now, who does this work? Historically, it's always been done by trained practitioners, operations researchers, or also called math programmers or math modelers. Those are the three terms used to describe them. So historically, these people have gone to school to learn this and decided to specialize in it. Most of them have advanced degrees. But that's not an exclusive club, and I'm an example of that. I don't have an advanced degree in one of these fields, but I'm a practitioner of math programming. And so it's totally within reach of people who don't have that hard math background. And that's why I'm speaking to you. I think we already know that data scientists have shown a good success rate in adopting this technology, and that's why we're talking here today. But you will run into this a bit. There's an organization called Informs.org where there's a really dominant organization for these practitioners to share ideas. And I encourage you to go there and look. There's a lot of good literature there. When you're working on a particular problem type, you can find a lot of good information there. The product that these people produce is a math model. It's a chunk of code, and the math model becomes the element that's integrated into a larger application if the need exists. So I'm showing a math programming model here. I'm not going to try to work through this code. It's just here to give you a graphic to look at. We'll go into code in more detail in a couple more slides. But I want to talk about how these models are used in an organization. So they're really no different than the models you already produce as data scientists. In our case, these are producible in any language. By that I mean Gurobi supports virtually any language you want to use through various APIs it provides. They're just included with the product. And now with the objective here, though, is quite different from what you're doing with machine learning. In the case of math programming or prescriptive analytics, we're writing a model that simply describes the solution. It says nothing about how the solver should try to find the solution. And that's a key point here. You're really handing this off to a black box. And that's a solver like Gurobi. And so the model defines variables. I'll show you this in detail in a moment, but it'll find variables that the solver should fill in with values. And it sets limits on the solution. We call these constraints. I'll go into more detail on these specific points in a moment. But the key point in a mathematical programming model is it includes a goal, an objective function, we call it. And so with those three components in place, the model then will tell the solver to go do its job. In the code at the left, using our API, the Gurobi API, we're telling the model to optimize itself. And that is where Gurobi is really starting to do its work. And then when it's done, your model code will publish the results somehow. Usually, in the simplest case, it'll print it to the screen for an analyst to use interactively. They'll carry it, or maybe they'll print it out on paper and carry it over to a manager and say, here's the plan for today, something like that. But more commonly, there will be a user interface wrapped around this, and you'll present the results in some graphical way. If you go to demos.gurobi.com, you can see a lot of examples of that kind. But then also, probably the most common way to publish results is to simply put them into a database or a web service of some kind. And there are lots of systems running in the world today that are using the output of one of these models in their day-to-day operations, or literally minute-to-minute operations in many cases. And so that the data that's injected into the database becomes an integral part of the regular operations of a large organization. And so that covers the last bullets on that slide. But the key to all this, because this is integrated into day-to-day operations, I think it's fair to say most of the time, a majority of the time, certainly, yes, it's fair to say that performance is a critical aspect of this. So if you write a model and it's part of an order processing routine, and a person placing an order is waiting for the response, you can't have the solver taking a terribly long time to come up with the answer. So that's one example. There are myriad examples of this kind. Performance is critical, and that's why at Gurobi we focus on performance above all else. It's a reliable solver that's not compromised, but there are lots of ways to write a solver to make it work, and Gurobi is always focused on performance as top priority. And so the red line is our progress on integer problems since our founding release of 1.1, I believe was in 2008. And you can see the increases here are dramatic. I mean, the increases in the beginning were considered dramatic too. People were then, around version 6, they were solving problems thought impossible 5 years prior, that it was not practical to try to write models of the kind that they were solving with version 6 of Gurobi. And that was at 5 or 8x our original performance. We're now at 70x. And again, I'll reiterate, add in machine improvements, computer hardware speedups, and we're doing it's a whole new world. It's a completely new world. And in fact, we must also talk about the availability of data has changed this as well. We're doing kinds of real-time operations. We didn't used to see that not long ago, like 10 years ago. Real-time operations, not really a common thing. And today they're becoming really commonplace because all of this has gotten so fast. So that's what it is. I'm sure there are questions about that, and if you have them, please put them in the question box. So there's a question mark